Cycloalkanes, these are cycles that have carbons in them. And because they are cycles, they do have a DBE equal to 1. Their formula for the cycloalkane is CnH2n, which is similar to the alkene. It's the same molecular formula as the alkene. So when you do the DBE in there, it's going to be DBE equal to 1. So this is going to give you structural isomers as either an alkene or a cycle. So you have to write both of them. Cycloalkanes are different types, and there we're going to stop at the cycle of 6 carbons. So whenever you want to name a cycloalkane, the cyclo needs to be before the alkane. So this is a 3-carbon cycle. Then it needs to end in a propane, but it is a cycle. It is not a chain. So this is why you have to put the word cyclo in front. So this is cyclopropane, cyclobutane, cyclopentane. This is how you draw it. It's just like put those carbons in there, the points in there, and then connect them together. You can draw it like this, you can draw it like this. Really, it doesn't matter. Both are going to be the same. This is going to be cyclohexane. Cyclohexane, you can either draw it like this or you can draw it like this. So whatever method you use is the same, as long as you're representing a cycle of 6 carbons in there. So as we said, the C in the cycle, this one needs to be capitalized because cyclo is part of the name. There's a difference between a propane and cyclopropane. Whenever you are naming cycloalkanes, the ending is always going to be in the cycloalkane, whatever that cycle carbon number is. And always the substituents on the cycle, you need to give them the lowest number possible. Now, if you have a monosubstituted cycle, meaning that just one substituent you have on the cycle, no need for you to give it number 1. It's automatically number 1. So when I want to name this is going to be called ethyl cyclopropane. I don't say 1-ethyl cyclopropane because there's no other substituent in there. And the rule says that if there's only one substituent on the cycle, I have to start numbering from that substituent. I don't have an option. So that is going to be the same. And you can start numbering from here always in there. For this structure, again, it's 1 there. So both of these are named the same. And if they are named the same, then they are the same. This is called a monosubstituted cycle. A monosubstituted cycle is a cycle that has only one substituent. Now, for cycles that have 2 substituents, if the 2 substituents are on the same carbon, there is no cis and trans. But if they are on different carbons, then definitely there is cis and trans. And cis and trans is included in the name. So when I want to name this is going to be carbon number 1. Always give the substituents the lowest number possible. So the name here is going to be 1,1-dimethyl cyclopropane. Okay. For this structure over here, the substituents are on the same side. So that is going to be cis. And then you have to give those, so since that there are 2 CH3s in there, it really doesn't matter which one is 1, which one is 2. So that is going to be cis-1,2-dimethyl cyclopropane. And there is no space between the dimethyl and the cyclo. It's just one word. Guys, pay attention that if you have different substituents, then you would need to alphabetize. But since here I don't have different substituents in there, I am just going to go ahead and connect those together and put the prefix di in there. There's a big difference between a propane and cyclopropane. So you cannot skip the cyclo. Cyclo is a must. This one is going to be trans. So as you can see, the cis and trans, they are included in the name. And that is going to be 1,2-dimethyl cyclopropane. If you don't put cis and the trans, this means that you are not specific. This means that it is a 1,2-dimethyl cyclopropane. This means that your dimethyl cyclopropane is this. So you have your 2CH3. So you have a CH3 here and the CH3 in there. You got to put their orientation. What are they with respect to each other? Are they on the same side or are they on opposite sides? So you have to be very specific when you have two substituents around the cycle to label them if they are cis or if they are trans. Two substituents around the cycle, this is going to be cis and trans. Here they are opposite, so that is going to be trans. The substituents are the same, so I can start numbering whatever I want, but from one of them. So that is going to be 1,4-dimethyl cyclopropane. Okay, there's another way if you don't want to show the wedges and the dashes. There's another way in there to draw the cycle like this and to draw the substituents on the same side like that. Or draw them on opposite sides like this. So this is a representation of a cis stereoisomer, and this is the representation of a trans stereoisomer in there. And both of these are geometrical isomers. So these two, the relationship between them is geometrical isomer. Now, as you go for more substituents now, you no longer use cis and trans. So this is a tri-substituted cycle, meaning that you have three substituents in there. So you want to give your substituents the lowest possible number. This is the rule. So in this case, I need to start from numbering from this carbon over here so that I can give the second substituent the lowest number. Okay, see how did I go? I went this way in numbering and not the other way around, because the other way around in here will give that substituent greater than carbon number 2. CH3s are the same, so that is going to be trimethyl, and then you give the numbers in there, and then the ending cyclo is part of the name. You have to end your name in a cyclo. Okay, here the substituents are different. If the substituents are different, we're going to go with exactly the same rule in there. You have to give your substituents the lowest number. But in this case, you guys, if you take a look, starting from here, carbon number 1, or starting from here, carbon number 1, is going to be the same. Why? Because the second substituent here is on the second carbon. So the numbering is going to be the same. So if this is the case, you need to start or to arrange the substituents by alphabetical order and start with the first alphabetical order substituent to give it the lowest number possible. So ethyl and methyl, E comes first, so this is why I'm starting the numbering from the ethyl and I am giving it the lowest number possible, and then you have the 2,3-dimethyl cyclohexane. Okay. Here I do have more than 3 substituents. It's fine. Rule is to give the substituents the lowest number possible, or the lowest sum of numbers possible. So whatever route you go with, I need the route which gives those substituents the lowest number possible in there. So normally, whenever you have 2 substituents on the same carbon, it's most likely that I would start with that as a number, because these 2 substituents now will get the lowest number. So this is 2 substituents out of 4 will get the lowest number. So this is why I start with here. And then I need to move this way because this is the second substituent and I'm going to give it the lowest number possible down to the ethyl group. Put the names in there. Sec is not part of the name. So you have to look at the B, at the M, and at the E. B comes first. So the name is going to be 2-sec-butyl. On carbon number 5, I have an ethyl. And then on 1, it's 1,1 and dimethyl. Don't forget, the prefix is very important. If you drop the di, your name is going to be wrong. Even though everything is right, if you drop di, the name is wrong. And then it's going to be a cyclohexane. Now, let's say, for example, if you have a carbon chain that has more carbons than the cycle, then how are you going to name? In this case, the rule says that if your carbon chain Notice here that my cycle is 5 carbons, right? This is 5 carbons in there. And then my chain here, let's count the carbons. It's 1, 2, 3, 4, 5, 6, 7, and 8. So my chain is 8 carbons and my cycle is 5 carbons. Which one is going to go at the end? Which one is going to be the parent name? The rule says that the chain which has more carbons is the one that is going to be the parent name. So here in this case, my cycle will be a substituent and my chain will be the parent name. So my ending is going to be an octane and not cyclopentane. See the difference in there? Up there, I had to end in cyclohexane, because I didn't have a chain which has more carbons than 6. So 6 was more than 4. So this is why my ending is in the cycle. But here, my chain has more carbons than the cycle, so the ending is going to be in that chain. And then I would need to give the substituent, the first substituent, the lowest number. So I have to start in number from this side. So the name is going to be 4. It's going to be cyclopentyl now. Okay, not cyclopentane. It's going to be a cyclopentyl. And then let's move octane over here so that we don't have a space. And then octane. For this one over here, take a look. I have a cycle of 4 carbons, and then I have a chain of 1, 2, 3, 4, and 5. Remember what I said, your chain doesn't need to be straight. So I have a chain of 5 carbons, 1, 2, 3. This is 4 and this is 5. And then I have a cycle of 4 carbons. In this case, then this is going to be my substituent that belongs to the longer chain. So I'm going to name this as a 3-cyclobutyl, ending in YL in there. Drop the A and E, put it in a YL because it's a substituent, and only the parent chain ends in A and E. That is going to be pentane. Same idea over here. This is 9 carbons. The cycle is 6 carbons. So this one is going to be a substituent. I'm going to name it as a cyclohexyl. When I'm alphabetizing, C is the one that I need to look for alphabetizing because C is part of the name. I need to look at the M in the methyl there. And then I have a bromine. I have a bromo. So B comes before the C, before the M. So on carbon number 1, give it the lowest number, 1 bromo, 2 cyclohexyl, and then on carbon 6 I have 6,6-dimethyl, and then the parent name, which is nonane. For this one, I'm going to choose the longest carbon chain. The longest carbon chain here is going to be, notice what I did. I started my longest carbon chain, including all the substituents. So try to include as much substituents as you can. And that is going to be my longest carbon chain. I'm going to start numbering from this end here to give the first substituent the lowest number. This is 3, this is 4, this is 5, this is 6, this is 7, this is 8. This is the table that I was talking about that has the names for all of these substituents. So NO2, we're going to name it as a nitro. If I had an NH2, I'm going to name it as an amino. And this one, you can have it in the exam as well. On eCampus, there is a table. In that table, it has all the information that you need. You can simply print that and bring it to the exam. So if I want to name this, then the name is going to be on 5. I have a cyclopropyl. So the cyclopropyl, the C comes first. So that is going to be a cyclopropyl in there. And then I have the methyl. I have 3 of them actually. On carbons 3 and 6. So I have a 3, 3, and 6. I have a trimethyl. The M is going to come next in there. Okay. And then, of course, the nitro, it's an N, so the M comes before the N. So that is going to be a 2 nitro. And then the name is going to be octane, so that is going to be octane at the end. There's only one reaction for alkanes that we are going to talk about, which is the burning of alkanes, which is combustion. It's the burning in presence of oxygen. Whenever you are burning alkene burns in presence of oxygen. It will give carbon dioxide and water. Alkenes can have too much carbons, so balancing the equation is kind of like a headache. This is why there is a general formula for these equations, and this also is included in the cheat sheet that you can have it in your exam. N is the number of carbons in there, and this goes towards complete combustion. Complete combustion is whenever you burn alkanes and your product is carbon dioxide and water. Okay, now if you want to go incomplete combustion, then your product is going to be carbon monoxide and water or carbon and water. So these are two examples of an incomplete combustion, but a complete combustion always gives you carbon dioxide and water. So the question here, write the complete combustion reaction of the following alkane and make sure that the reaction is balanced. In order to do this, I would change this into a molecular formula. So let's go ahead and count the number of carbons here. Again, this type of question can be really easy once you change it into a molecular formula. So it's 3, 4, 5, and 6. So that is going to be C6. And it's going to be, it's a 2 and 16. This is going to be 12, 13, 14. So that is going to be C6H14. I simply counted my hydrogens in there, or you can apply the formula CnH2n plus 2. Okay, so my n is equal to 6. So if I want to go ahead and balance that, that is going to be equal 3 times 6 plus 1 divided by 2. Okay, and I'm going to end up getting 6 carbon dioxide plus it's going to be N plus 1, which is 7 water molecules in there. 6 times 3, this is 18. 18 plus 1, this is 19 over 2. So this is going to be 19 over 2 oxygen is going to give me 6 carbon dioxide plus 7 water molecules plus, of course, my C6H14. Now, sometimes it's hard to write the fraction in there. So in order to get rid of the fraction, I'm just going to multiply this whole thing by 2. So to multiply this whole thing by 2, I'm just going to take this 2 out, and the balanced equation is going to be like that. It's going to be 2C6H14 plus 19 oxygen in there. That is going to give me, you're going to multiply the 2 by each one of those. So you're going to multiply the 2 by carbon dioxide. So that is going to be 12 CO2 plus 14 water. And that is going to be your balanced equation. Guys, it doesn't matter how big your alkane is. Change it into a molecular formula. And then from that molecular formula, do the substitution in order to get to the combustion.